Assalamu alaikum. My name is Muhammad Alal Khan 221714. So today we are going to discuss assignment 2 question 1, in which we are going to simulate some of examples in Proteus. So our first problem is write an AVRC program to send hex values for ASCII character of D012345CD to port B. Okay. First of all, we initialize uh, array of my list array of 0 1 2 3 up to D, right? Then we declared character Z. After that, we declared port B as an output, and we initialize a for loop from 0 to 10 because we have 0 because we have 10 total characters of ASCII which we are going to send to port B. After that, we are sending the characters to port B, like by port B is equal to my list Z. Let's run this code in Proteus. So I already write this code in Proteus. Let's run the simulation is if it's working. So if we see it's our code is properly working here, it's in working condition, right? So let's go towards our second problem, right? Control A, Control C. So this is our second problem, which we are going to discuss. Our problem is 774. 7.4 example says write an AVRC program to send values from of -4 to +4 to port B. So for -4 to 4 we are not using unsigned, we are using signed. Okay. So car, my name, we declared from -4 to 4 all these. After that, we initialize character Z because we are going to use it in our for loop. That's why we are declaring port B as an output. After with that, we start a for loop 0 to 8. 0 to 8 means 0, it will go from 0 to 9 because we have -4 to +4. These are total 14 characters, 14 values. After that, we are sending these values on port B, right? So let's run this code and see what's happening, right? So we can see the code is properly running. It is in a running condition, right? And if you see, LED is blinking and everything is working exact properly, right? Again, we can see the code is working properly. It's basically -4 to +4. It's basically -4 to +4 everything, right? So this was our problem 7-4. After that, we are going to perform 7-9, problem number 9, right? I already wrote the problem. Control A, Control C. So what is problem number 9? Let's see. It says we have to write a code which add, or we can write to get a bit of data from port B and send it to port C. So this is basically the code which we are going to write. We are going to data from port B and send it to port C, right? Let's run this simulation. Okay, if it's working or not. Yeah, so this code is also in a working condition, right? After that, we are going to discuss example 711. So our another problem is example 11.7.11, which says write an AVRC program to get a byte of data from port C. If it is less than 100, send it to port B, otherwise send it to port D, right? So we have ports, we have three ports C, B and D. So B and D will be output and C will be declared as input. After that we declared unsigned character temp, we are declaring a temp, and we are sending value of port C to temp, and then we are comparing it. If it is less than 100, so we are sending value to port B, else we are sending that value temp, cause we have pin C value is in basically is in temp, so we are basically sending the value of pin C to port D, right? If it is greater than 100, so we will send it port D. So let's run this simulation in Proteus. So as you can see, it's working, it's in a working condition, it's properly working. Let's try this, right? So if we can see, the code is properly working. We can see here that we are seeing that the value is greater than 100, so we less than 100, so it is sending the value to port B, right? So this code is already working, also working. Let's go towards our next problem, which we are going to discuss is example 7, 11, 12, right? Which says run the following simulator and examine the following problem, which this problem basically says DDRB is equal to, we are declaring port B, C and D as an output. Port B is equal to 0x35 and 0x0. F means we are adding these and it is an AND operation, right? On port C we are doing an OR operation, and port D we are doing an XOR operation, and port B we are doing an invert operation, right? So let's do one thing. We will do like, we will declare it as an output as well, right? And as we can see here, port B is equal to 0x10 and 0x AE, or is it AF, right? So we will run this problem. It's basically an AND operation, right? We are sending this to port B, and this code is working exactly properly, right? Let's move toward our next problem, which is example 7.14, which says write an AVRC program to monitor bit 5 for port C. We are only specifically targeting bit 5 for port C. If it is high, we will send 55 to port B, otherwise we will send AA to port B, right? So this is example 7.14. So this is the problem. Let's run the simulation. Here you can see what we are going to basically doing in the code is we are specifically targeting bit 5 and then we are sending 0x55 to port B. Okay, so so if we see this code is working exactly properly. Why? If we see the code, we are declaring port B as an output, and the output is on a port B, right? And what we are uh, doing is we are sending value 0x55 on port B, which basically means 100101101 like that. So it's properly working here in this case. So our this problem is problem number 14 is also working properly. Now let's move toward our next problem, which we are going to discuss is 17, problem 17, right? So I already wrote problem 17. So in problem 17, what we are going to basically to do is write an AVRC program to read pin 1 to read pins 1 and 0 of port B and issue an ASCII character to port D according to the following table. If 00 send 0 to port D, if 01 1 0 1 0 2 1 1 3. So if we see here, we are declaring port B as an input and D as an output. Then we are declaring temp and check. uh, uh, After that we are sending the value of pin C to temp, right? After that we are performing an AND operation with last two bits, cause we have two pins, pin 0 and pin 1, right? What basically doing here is, if we have if pin 0 and pin 1 is 0 0 and temp value is 0x00, then in AND operation what we will get basically is, here is 0 0 with decimal 0, so the value will go to 0, right? If we see here, if we have pin 0 and 1, then it will show like that in binary 0000001, and we have declared it is x00001111. So AND operation will give us 1, right? Now after that we are using switch and applying switch on check. We have case 0, in which we are checking 0. If it's 0, we are sending value on port D, and after we are breaking it. If it's 1, send value to 1. If 2, send value to on port D of 2. If it's 3, we are going to send value of 3 on port D, and so on. So let's run the simulation and see what's going on in this operation. So as we can see, wait a minute, B and D, okay. So we can see here we are getting our output. So this code is also working properly. Let's run our next problem, which is 725. Let's run this as well. Right. Let's see problem number 25. What it's saying is basically Okay, a door sensor is connected to port D pin 1 and LED is connected to port C pin 7. Write an AVRC program to monitor the door sensor and when it's open turn on the LED. Right. So we are defining LED 7, 7 bit for an LED and bit 1 for sensor. Right. After that we are declaring sensor bit 1 as an input and LED 7 bit as an output. After that we are checking if sensor bit means we have if our bit number 1 of sensor of pin B is on, show output on port C, otherwise clear the port. Right. So B and C. So this is our simulation. We can see it's working here properly. Right. You can see it's working properly. Let's move to our next problem. What be the LED number, and if we want to see LED right, as we can see it's working properly because we declared for pin 7 of port B as an output, so we can see we are getting our LED on in this case. Right. On off. So we can see this code is also working exactly properly. Let's move to our very next problem, which is 27. Right. Let's move to question number 27. Let's see what in this problem. Write an AVRC program to convert ASCII of digit 4 and 7 pegged BCD and display them on port B. So what we are going to here is bit conversion. We are going to basically convert data conversion. Right. So we are going to convert this data. First of all, for that purpose we initialize a BCD byte, or if we see here, first we declared DTRB is an output, unsigned car X as 4, Y as in 7. After that we are performing an AND operation, X with 0x0, which means that we will get 4 as it is. Right. And we will get 40. Right. We will get 40. After that we will shift this of 4 bit towards right, so it will become 4 to 40, and it will become from 4 to 40, and we will get 7 as it is. Right. Wait, it is F0. Right. Now it's good. After that y is equal to y, and operation of on y means on 7, we will get here 7, we will get here 4, which will be converted into 40, and we are applying AND operation, and if 40 and 7 equal 47. Right. So we will get here 47. So basically this is going on here in this simulation. So if we see, the code is working here as well as properly. We are getting the value of 47 on port B. We see it's working properly. We are getting value of 47. If we convert it in our binary, 0 0 1 1 1 0 0 1 0, right? So basically this is our problem, which is working properly in this case, right? Let's run our very next problem, which is problem 30. Problem number 30. And 31. Problem 30 and 31. See, so in this problem what we are going to basically doing is we are converting this 11110 or FD to decimal and displaying it the values on port CD, right? So for that purpose, first we initialize X pin byte D1 and D2. Then we initialize all these ports as an output. We are sending FD on pin byte, right? Then we are doing an operation like we are dividing the pin byte, we can say the FD on 10. After that we are taking modulus, finding the least significant digit by doing this operation. D1 is equal to pin byte and 10. After that we are performing D2 is equal to X and 10 for the middle digit, and for the most significant digit we are doing dt is equal to x divided by 10. So we will get our least significant, middle and most significant digit. Let's run this code as well on Proteus, so get the data. Let's run this problem. So here we can see it's working here properly. Port B on port B, on port C, on port D we are having in our outputs. Here we have one here on port D of 1 1 1, and here as well. So if we connect it like this, right, we will get our desired output. So this code is also working exactly properly, thanks to Sir Umar Farooq. Right, let's move on to our very next problem, which is 31 is also done. Let's move to our last problem. Thanks God, to our last problem, right? So this is our last problem, question 34. It is 34, yeah, it's 34. What it's saying: write an AVRC program to bring in a byte of data serially 1 bit at a time via port C pin 3. The least significant bit should come in first. Okay, so we are going to send the least significant bit first serially to port C pin 3, right? For that purpose, what we did is define pin 3, right? After that we did what initialize character X, and we initialize another in another variable rega which we take as 0. After that we declaring this 3 serpin 3 as an input on this operation ddrc and equal to not 1 greater less than serpin. So this operation is basically making this serpin pin 3 as an input, right? After that we start a for loop from 0 to 8, right? Because we are sending each value 1 1, like 0. We have total 8 bits, so 0 to 7, 0 1 2 3 4 5 6 7, right? we are we are sending in we are sending these values one by one, and what we are doing is after that, after sending one bit, we are serially shifting one bit to the right on this operation reg is equal to rega greater than 1. This operation is basically shifting rega, or each bit one to the right side, right? After that, what we are doing here is rega, or is copy the bit of sirpi to port C of most significant bit of regba, right? So let's run the simulation and see what's going on here. Right, xrga. Okay, we declare it as an output x up to 8. And our last problem is in which we are doing this problem. So basically we have unsigned character x, this as we discussed. So let's simulate this the problem again. So as we can see, the problem is running. Basically I made some changes here, like I am sending the value of serpin, basically of r this rega and serpin to port B. So we can see what's going on here, right? So if we start it, we will get our output properly, right? As we can see here, it's working properly. So this was for today. Thank you so much. Hope you like my video. If you like my video and get some information from it, subscribe and like. Thank you. Allah Hafiz.